Okay, so today we're going to cover about quadratic functions, and this is essentially an extension of what I did in chapter 4, like an extension of the explanations. From what I personally remember, I think I've covered like most of these already in chapter 4, so chapter 4 was about equations, yes. Okay, so as a review, quadratic equations is in the form of ax squared plus bx plus c. And graphically, it's commonly in the form of a parabola, like in this form, or in this kind of form, depending on the equation of the function. And so the most basic form of a quadratic equation would be something like this. Where the minimum point is in coordinates of 0 with the equation of y equals to x squared. So this is pretty much their basic well-known form of it. And to review, there are several terms in the parabola that you need to know. So like I said before, this U shape, whether it's up or down, this is called the parabola. Well, this point is what you call as the minimum point or the maximum point. So the minimum point is also known as something called vertex, which is vertex is specifically the turning point. Well, the minimum or maximum point is the like its own name, the minimum or maximum of its point in the graph. So in this case, this is called a minimum point. You have a maximum point when you have the upside down U kind of graph, where the you have the highest, like visually the highest point in the graph, like this. And then in this graph, you also have this thing called an axis of symmetry. So typically in the parabola, the shape of the graph looks like a mirror of from one side to the other. And that is why we have this thing called an axis of symmetry. It shows that it kind of like shows the division of the graph. And usually in quadratic functions, it is in the same range of the minimum or maximum point or the vertex. And then you also have the x-intercepts. So the x-intercept lies in the x-axis. And usually these are the points where you find the roots from the quadratic equations. Like for example, if you have x minus q, x minus p, then the points here would be q and p. And then last but not least, we have the y-intercept. So the y-intercept is the point that intersects the y-axis. Okay, so as we learned before, there are two common quadratic forms, which is this form, which could be factorized in into a x minus p times x minus q, and also another form, which is the a parenthesis x minus h squared plus k. So these functions have their own properties. For this function, its properties, like I said, like I explained before, is that you can get the roots of the x-intercept, which is this and this. So how you can find it is essentially you try to make it so that the equation equals to 0. And you try to find x when it's 0. So you can, since this is multiplication, you can pretty much conclude that x something times something equals to 0 is kind of like saying this part can be 0 times this part can be 0 equals to 0. And since a is a constant, a must be a number. And then from this, you can say that x minus p equals to 0 and x minus q equals to 0 and work it out from there to find the value of x, which is p and q. It also have the axis of symmetry. So when you have a graph like this, and you want to find the axis of the symmetry, how you find it is from adding the values of the roots and dividing it by 2. So in this case, it would be p plus q over 2. The reason why it's like this is because, like I said before, the quadratic functions have this property where they can be mirrors of each other in the axis of symmetry. And since if you have 2 roots, then looking for the axis of symmetry is kind of like looking for the midpoint or the middle between the 2 points. So that's why you find the axis of symmetry by adding 2 points and dividing it by 2. And then in this case, the vertex would be this point. And usually in this form, the vertex would be something like this. So as you see here, actually not necessarily, it can be something like this too. The vertex is the turning point, so finding this gets you the x coordinate of the vertex. So if you want to find the y vertex, you just need to insert the x's to find y, and that's how you find the x and the y coordinate of the vertex. Okay, so now we have the y equals a times x minus h to the power of 2. This is actually the same thing as the one with the plus k. Wait, actually, to write it more appropriately, it would be something like, yeah, let's just say this. So the difference between this and this is that in this version, the k is equals to 0. And basically, the purpose of the k is to kind of like shift the graph. So if you have something like this, you have a times x minus h squared, then most of the time the vertex is um, something like this. Let's just say it's something like this. And then if you add k, then it might shift the graph into something like this, or it might shift the graph into something like this. I know my drawing is horrible, but basically the shape of the graph is going to be the same, but it's just moved upwards or downwards depending on the value of this. So you can kind of say that this is like, this is the up and down shifter in the context of this. So if they have something like this, that means that it touches the x-axis in the h. So like, it can be, for example, if you have something like this, it means that you only have h as the x. So it's kind of like a shifting kind of thing, but this time it's a horizontal shifting. You see now, the h works as a horizontal shifting, while the k works as the vertical shiftings. And so if you have something like this, the axis of symmetry would be the h, and the vertex would be h and 0. You write that appropriately there. And then if, again, like I said before, if you have plus k, that means that it shifts upwards. Okay, so there are several properties which you can kind of like know from the function itself when you have ax squared plus bx plus c. So if a is more than 0, if a is positive, then the shape of the graph would most likely look like something like this. Or like this. Basically, it will look like a U. But if the A is negative, less than 0, basically like -1, -2, blah, 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 anything that goes with minus, then the graph would look like an upside down U. Something like this. And but then they also have something interesting going on with the values that you have. So if you have a graph that is more than 1, so I mean, when I say more than 1, I mean the a is more than 1. So let's just say 2x squared or 3x squared. Then the graph is going to become very narrow. So for example, if this is initially x squared, then the graphs with 2x squared would look something like this. And then the graph with 3x squared would be tinier and it would look something like this-ish. But then if the graph is something like 0.5 x squared, then it would look flatter. And as the value decreases, it will also um, become flatter and flatter. That is, if it's lower than 1. So you can see like the trend in the graph. If you have 0, it's kind of like saying that you don't have the x squared. So it's kind of like saying the graph is flat or it doesn't have a parabola. But then it's, if you slowly like add up like 0.2, it's making a graph, but it's very wide. It goes narrower and narrower as you lower the value. So as you go from like minus 0.2 to minus 2, it changes the narrow and wide size of it. Okay, so after knowing the values, we also have sketching the graph. So if you have an equation, let's just say you have 2x squared plus 3x plus 6. And you want to graph this thing. How you do it is that you have to start by completing the square. But before completing the square, you need to make sure that the x squared only has 1 as its coefficient. So basically, it has to be something like x squared plus bx plus c. So to change that, we factor out the 2. So that becomes 2x squared plus 3 over 2x plus 3. So now you have it factored out. And then after doing that, you're going to try to complete the square. So you want to try to make, you want to manipulate the algebra so that you can make it so that there's a square plus a value. And since this is a regular equation, you need to make sure that the equation is balanced, right? You don't want to like add a value for no reason. So how you do it is you kind of manipulate the process of it by doing square plus, let me rewrite this. You do it by adding a value in here and then minusing the value by itself equals to 0. And then you add a bracket here to make it so that we kind of like isolate the value that we want, and so that we can factorize it into a square. Okay, so if you want to find the value of c from b, we have to look back at the properties of squaring. So if you have something like this, it would be x squared plus 2xy plus y squared. So this is basically like saying square root of c since c is this value, but then we want you want the c in this value, right? So square root of c, 2 square root of c times x equals to b. If you get my point, because okay, this might seem a bit too confusing for you, but it's just like kind of like I want to get, let's just say like y squared is equals to c, and then you want to get y, right? So in this case, you need to square the c, and now you get the y. And then to insert it in this form, then you would get some like 2x times square root of c, and that's the equivalent of b. So um, to find c in terms of b, then you need to do b over 2. So you move the 2 into b, which becomes b over 2 equals to x square root of c. You also move the x in here. Um, yeah. Okay, so in this case, the x isn't included because in this form, it is bx, right? And then in this form, it's 2xy, so technically it should be 2y, my bad. And then you square the bx over 2, so you get c. So if you want to insert it, then since in this case, 3 over 2 is equals to b over 2. 3 over 2 is equals to b. If you want to get c, that means that you have to do 3 over 2 to square root of 2. And because you added this value and we want to make sure that we balance the equation, we also add the same value in here, but this time it's minus. So from this, we can make it so that it is 2 times x plus 3 over 2 divided by 2 is basically the equivalent of times 1 over 2 square plus 3 minus 3 over 2 times 1 over 2 square goes to 0. And let me erase this part. This is a bit lagging, so it's going to take a while. This is seriously lagging really bad. I'm so sorry, guys. Like, I literally can't control, like, I'm using an art tablet and I cannot control my pen. Okay. It's better now. So back to this. This becomes 2 times x. Forgot to add the big cage. 2 times x plus 3 over 4 square plus, so 3 over 4 square becomes 9 over 16 if it's squared. And if you add it by 3, that gets you 57 over 16 equals to 0. So from this, you can find that the vertex or the symmetry of it the axis of symmetry would be somewhere in 3/4. So if this is -1, this would be like this is the axis of symmetry. Oh yeah, and keep in mind that the equation is x minus h squared, a times h x minus h squared plus a plus k. So this is minus and this is plus. So if the value here seems positive, that means that the h is -3/4. So that's something like to keep that in mind, because sometimes people forget or don't realize about that. Okay, so for the next part, you need to, since this is still in a bracket, you need to open up and multiply it by 2. So that becomes 2 times x plus 3/4 squared plus 57/16 would be, if times 2, that would be 57/8. And that's like 7.125. And as we said before, the vertex of this particular equation is hk. So if let's just say this is 7, so 7.125 is somewhere here. And since this is positive, that means that the shape of the graph is something like this. And if you want to find the values of the points, you just insert this graph into y equals to 2x plus 3/4 squared plus 57/8. So if you want to find the y-intercept, you just insert the x with 0. So that would mean 0 plus, that would be 0 plus 3.4 squared times 2 plus 57/8. And then calculate all of those, that would get you your y-intercept. Because if you're drawing a graph, especially in IB, it's fine for you to draw an estimate of the graph, as long as you tell where the vertex point is at and you tell where the y-intercept is at. But then if the graph, for example, it touches the x-axis, then you need to show where the x-intercepts are at. So yeah, in IB, you don't have to, if you have questions asking you to draw a graph, you don't have to accurately draw it like literally centimeter by centimeter. You just need to make sure that the values in the minimum, maximum, the axis of symmetry, and all the properties I mentioned before were given in the drawing. Okay, so this is probably taking too long. So next up, we have the general form. Since the axis of symmetry is x equals to h, if you have the general form, then you have the axis, to find the axis of symmetry, you have minus b over 2a. And you might be wondering, like, why is the axis of symmetry this? Like, where does it come from? It actually comes from the proof of completing the square. So, like I said before, and like I explained before, the c equals to find the c, like to get the x minus h squared, if you caught up, you need to like condense the x plus bx plus c. And to condense it, you get c as b minus b over a. B, my bad. You get b over 2. So that is assuming that the graph is positive. So this is getting really confusing. So let me just re-explain this and like re-explain all the steps, because I think like if I try to explain this like the way I did before, it would be very confusing. So like I said before, the form of x plus y and x plus y, like x plus y squared, equals to x plus 2xy plus y squared. So let's just make it so that it's in the form of 2yx plus y squared. Let's just make it in the form of ax squared plus bx plus c. So in this case, the b would equal to 2y, and the c would equal to y squared. And okay, you know what? Let me just redo this again, and like let's just do this. Yeah, x minus y squared. Since this is like x minus h for neater results. I'm so sorry, guys. So this would get you x squared minus 2xy plus y squared, right? And to put it in like the context like before, that would be ax squared minus bx plus c. So this is comparable. Let's just say this is one, this is, yeah. And so to get the value of c, let's just say that c equals to y squared, since they're the same, right? And then b equals to 2y. So if you want to insert that in the equation, y equals to b over 2, and c equals to b over 2 squared. But in this case, you want to make it so that it gets inserted into this. So to get, since the y equals to the symmetry, axis of symmetry. So if you put it in here, oh geez. If you put it in there, that means that you're finding the square root of c equals to b over 2, since y equals to square root of c. But then the thing with this is that minus b. The thing with this is that it's in the case of when the a equals to 1. So if the a equals to like some number, like for example, let's just say 2, then you have to factor it out. So to factor it out, you do b over 2a. So it becomes like x squared plus x squared minus b over a x plus c over a. You get my point? So that's the reason why you have the a. And then for the minus, the reason why you have the minus is because if you have like the basic equation is ax plus bx, ax squared plus bx plus c. So if you turn it in this case, this is like the negative equation. So to like neutralize that, you have the minus. I'm sure that makes sense, but okay. So for the general form, that's how you find the axis of symmetry, by doing minus b over 2a, and then if they have the roots, then you can factor them out by minus b plus square root of b squared minus 4ac over 2a. This was actually explained in the previous chapter, and it also goes same with this. So if you want to use this discriminant to find the properties of the graph, you know that if you have a discriminant over 0, which is 1, 2, blah, 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 like a positive answer for this one, that means that you get 2 solutions or 2 roots. Now, if you have 2 solutions or 2 roots, that means that the graph is cutting up on the x-axis. But then if you have a discriminant that equals 0, you only have 1 solution. So having 1 solution means that the graph is just touching the x-axis. Well, if you get no real solutions, that means that the graph is not touching the x-axis. Okay, so from these properties, there's also some things you can know. For example, if you have ax plus bx plus c with a as positive and the discriminant as not a real discriminant, then you can conclude that the values you can pretty much conclude that all the values are positive. And it goes the opposite for the upside down u. So if you have negative values and I think this is supposed to be non-existent. Yeah, negative values and non-existent discriminant, then and then next up we have finding a quadratic from the graph. So if you want to find the formula of the equation, so ax squared plus bx plus c from the graph itself, then you can use the properties that I explained above to kind of like reverse work and look for the solution. No, look for the formula itself. I mean, I think Do I need to make an example? I suck at making examples, especially with graphs. It's kind of hard. Like, it's not like making up examples in statistics. Pro tip, just practice from questions. So the next up, we have the intersection of graphs. For the intersection of graphs, this is basically just saying that if you have a graph like this, and then you also have a line, let's just say like a line like this, and you want to find the points of intersection, then you just do ax squared plus bx plus c equals to the formula of this graph, which would be, let's just say mx plus d. So after you find this, you try to equate it in one side so that it becomes ax squared plus b minus mx plus c minus d, and then try to use the steps above to look for the formula. To look for the x-intercept. But in this case, it's more of like the x-intersections of it. And so there can be a lot of like types of intersections that come with it. And I think it also works the same with like inserting the discriminant to find if they have two roots, one root, or no root. Okay, so there are often times when the questions in the exams requires you to problem solve with quadratics. Sometimes the questions involve like let's just say the area of maximizing the area of a square. So in this case, clearly the values in the negative wouldn't apply and wouldn't work in this situation because the negative, how can you get negative values from finding the maximum area and length of, actually it's rectangle, I'm sorry, it's not square, it's rectangle, the maximum area of a rectangle. And this also goes the same with like other questions when you have, maybe when you try to throw a ball, like you wouldn't include this value as you wouldn't include any of these negative values or zero as a part of the ball that's thrown, because realistically that doesn't make sense. So you can apply boundaries to determine which values apply in this context. It's also the same with the how many people present thing. So basically, in real life situations, we usually just pretty much reject the negative solutions. Okay, and then we also have optimization. So like the example that I gave before, sometimes there are questions where they ask you to find the maximum area of a rectangle given that it's P and Q, and they ask you to like find a graph that shows, that helps you look for the maximum area of a rectangle. And when they try to ask you to find the maximum area of it, that's what you call as optimization. It's just a fancy word to call what is the min or the max point in real life. That's pretty much it. Like, it's just a fancy term. And then Last but not least, we have quadratic inequalities. So quadratic inequalities is basically what you do when you have an equation and then they ask you to find the values. There are wait, let me redraw it. The values that are positive and the values that are negative. So how you look for it is you try to insert this you usually try to insert this in the discriminant b squared minus 4ac. And then after inserting it, oops, my bad. Actually, I feel like I'm not. Okay, my bad. But I think I forgot this part, so I don't think I'm qualified to talk about this yet because I did cover this. I did learn about this, but then I forgot because this is like not one of my best. One of the best things I'm good at. So, but it's pretty simple. It's not that hard. It's just like it just happened to it just happened to be something that I'm not really like the best with. So like yeah, you know what? I don't think I can cover this today. So I guess I can cover it tomorrow before I start next session. So yes.